Hello students, today we will be discussing some problems related to ray optics. In fact, I will be discussing problems topic wise. First, I will be discussing problems on refraction at plane surfaces. In some of the classes, problems might have been discussed, but still, I will be discussing all examination problems and also the problems which are there in NCERT textbook and which can appear in exams. Right. Since I am discussing first of all the problems related to plane surface, okay, let us consider the formula related to this. In fact, the first problem that you can come across here is based on Snell's law. The idea is very important. Already you know, once you consider the refractive index of a medium, n is given by sin I by sin r. That is ratio of the sign of angle of incidence to sign of angle of refraction will be constant, and we call this as Snell's law. Okay, already you have that idea. Especially when I am writing the formula like this, basically we will be assuming that the light is traveling from air to some medium. Okay. For example, if the light is traveling from air to glass, already you know it can be written as Ng. Okay, that is refractive index of the glass with respect to air, and it will be equal to sin of angle of incidence in air to sin of angle of refraction in glass. If it is traveling from medium 1 to medium 2, then if it is traveling from medium 1 to medium 2, then we can easily consider this formula, that is n2 by n1 will be equal to ratio, that is sin I by sin r. Okay, this one we can utilize. After considering the formula related to Snell's law, basically in the textbook they have discussed about the normal shift. Okay, that is whenever an object placed in one optical medium, if it is observed from another optical medium, there will be apparent shift. Okay, and the apparent shift that is produced is what we call as the normal shift. Especially it will be taking place along the normal. Okay, and therefore we will be using the name normal shift, but it is only apparent shift. And also you have been given the idea, if the object is in denser medium and the observer is in rarer medium, the shift will be toward the observer. That means the object appears to be raised. Okay, it appears to be moving toward, basically the shift will be toward the observer. But if the observer is in denser medium and the object itself is in rarer medium, the shift will be away from the observer. Okay, the simple idea is, if a bird flying in air is observing some fish present inside water, the fish appears to be near. Okay, that means the actual distance between the bird and the fish will be more compared to the shift, that is the position that will be observed by the bird. But once you consider the fish, for the fish, the bird appears to be farther. Okay, because object is in denser medium, observer is in denser medium, object is in rarer medium, that is air, therefore the shift will be away from the observer. But more than all these things, a single formula has been given in the textbook, and based on that only problem can appear, and that is, once you consider the refractive index of a medium, it can be calculated by considering the idea of the normal shift, that is refractive index of the medium is given by real depth by apparent depth. Okay, therefore, if you know the actual position with respect to a surface and the apparent position, by considering the ratio of the real depth by apparent depth, you will be finding out the refractive index. Okay, these are all the formulae that we are coming across in case of reflection at just the plane surface. Okay, let us try to consider some problems related to this. In fact, I'll be sending the problem file. Okay, you can just note take down the problems in a sheet of paper, and then you can just watch the video whenever you want. Yes, the first problem. A tank is filled with water to a height of 12.5 centimeter. The apparent depth of a needle lying at the bottom of the tank is measured by a microscope to be 9.4 centimeter. What is the refractive index of water? If water is replaced by a liquid of refractive index 1.63 up to the same height, by what distance would the microscope have to be moved to focus on the needle again? Okay, and try to represent this problem in a diagram. Okay, because it's always better to consider the diagram related to the problem that we are trying to work out. A tank is filled with water to a height of 12.5 centimeter. Let us consider this as the tank. Okay. And inside this one, water has been filled, and the height they have given, and the height is 12.5 centimeter. This is the height to which water has been filled. A needle has been placed at the bottom. Okay, here is the needle, and with the help of the microscope, basically the needle is being observed with the help of the microscope. Basically, the needle appears to be revised. Okay, basically there will be apparent shift in the position. This is the virtual image that the observer will see when he observes this object present inside the water. Okay. Therefore, whatever 12.5 centimeter that has been given is basically works out as the real depth. This is the real depth corresponding to the system. This is the real depth of the object with respect to the surface where we are considering the refraction of light. That is, real depth is 12.5 centimeter. But the apparent depth of the needle lying at the bottom of the tank is measured by a microscope to be 9.4. This is the apparent position. Therefore, this distance is the apparent depth, and they have given the value of the apparent depth also, that is 9.4 centimeter. Therefore, real depth they have given, apparent depth they have given. Okay. Now, our job is to find out the refractive index of water, because we are considering initially water. We have to find out the refractive index of water. Okay, just now I mentioned the formula. Refractive index of water is basically real depth by apparent depth. Okay, real depth is 12.5 centimeter, and this is 9.4 centimeter. And once you find out the ratio, it comes out to be 1.33. Already you know refractive index is a dimensionless quantity. It's just a number. Therefore, 1.33 is the answer. Okay. Next. Second part is there in the problem. If water is replaced by a liquid of refractive index 1.63, after this water has been replaced by liquid. Now what is not there? Liquid has been filled here. Okay. And this liquid is having refractive index 1.63. The refractive index of the liquid has been given as 1.63. 1.63 is the refractive index. What actually we have been asked is, by what distance would the microscope have to be moved to focus on the needle again? Because the microscope has been focused to this particular one. This is the apparent position corresponding to water. Okay, when water is there, this is the apparent position on the needle. But now we are replacing this one by a liquid of higher refractive index. And if you just observe this one, Once the apparent depth if you consider from this, okay, it will be equal to real depth by refractive index, and in fact the shift. In fact, you can say the normal shift it will be equal to real depth minus apparent. Okay. Therefore, if the refractive index increases, apparent depth decreases, but the shift, that is apparent shift in the position of the object, increases. Okay, this is the basic idea. In fact, these ideas are required even for competitive exams also. Okay, normal shift is the shift that is there in the position. Okay, in fact, this is what we are considering as normal shift, and this is the normal shift corresponding to water. Okay, when the water is there, this is the position and this is the normal shift. But now we have replaced this one with liquid. Therefore, the apparent position will be different now. I consider this as the apparent position corresponding to liquid. That means the extra shift will be there in the position of the object because of the higher refractive index. Okay. Therefore, corresponding to this, real depth is same in both the cases. But apparent depth corresponding to the given liquid I consider as AD dash. Okay, AD dash is the apparent depth corresponding to liquid of refractive index 1.63. This is the apparent depth corresponding to water, okay, which I have taken. But this is the apparent depth. Okay, now similar to that one, here I can write again the formula. Refractive index of the liquid is equal to real depth by apparent depth dash. So this is the one. That's why apparent depth, if you consider real depth by refractive index of the liquid, real depth is same, already it has been mentioned, divided by 1.63, and this comes out to be 7.67 centimeter, because this is in centimeter. Okay, this is basically the apparent shift that is there in the liquid, the depth that is there in the liquid. But one important thing is you have been asked to find out this one. Okay, this is the height to which the microscope has to be moved further. Okay, ಇಷ್ಟು height ನ ಮೂವ್ ಮಾಡಿದ್ರೆ ಮೇಲೆ ಈಗ ತಿರ್ಗ ನಾವು ನೀಡಲು ಫೋಕಸ್ ಆಗ್ತದೆ. That is the thing. ವಾಟರ್ ಇದ್ದಾಗ ಇಲ್ಲಿ ಫೋಕಸ್ ಮಾಡ್ಕೊಬೇಕು, ನಾವು ಮೈಕ್ರೋಸ್ಕೋಪ್ ನ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಮಾಡಬೇಕು, ಎಕ್ಸ್ಟ್ರಾ ಮೇಲಕ್ಕೆ ಪುಷ್ ಮಾಡಬೇಕು, ಆ ಡಿಸ್ಟೆನ್ಸ್ ಈ ಡಿಸ್ಟೆನ್ಸ್. Okay, this is the idea they have given. Okay, therefore, once you consider this shift, we have to find out. Okay, ಇದು same. Okay, this will be the same. Okay, and I will consider this as x. This is basically x. Okay, ಇದು x to x. And therefore, from the diagram it is clear x is equal to, just observe here, this is apparent depth corresponding to water minus apparent depth corresponding to liquid. And therefore, apparent depth minus apparent depth corresponding to water. Okay, I'll write W also so that you can easily understand. Apparent depth corresponding to water, apparent depth corresponding to liquid. The difference we have been asked to calculate in this textbook problem. Therefore, and here apparent depth here is 9.4 minus 7.67. Therefore, the answer comes out to be 3, 14.67. Okay. And, here it is 9 minus 7. 8 minus 7 is 1.73. Yes, 1.73 centimeter is the shift, additional shift that has to be there in the microscope. Okay, this is basically the solution on the problem. Okay, send the problem sheet. Okay, first take down the problems in a sheet and then watch the video. Okay, that's more important. Just take the screenshot. Okay, then it will be easy for you to go through the solution. First, we considered water. The pin which was there at the bottom appeared to be present here. Afterwards, we replaced water by some liquid of higher refractive index. The position of the object has not changed, the height also not changed. Therefore, real depth has not changed. Therefore, the apparent position will be definitely different. In fact, apparent depth for the higher refractive index has to be less. That means the more shift will be there, and therefore the extra distance to which the microscope has to be pushed up to get the image again is basically x, and we have calculated the x, and it is equal to this one. Yes. This is the solution of the first one. Okay. Now, second, a small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeters. What is the area of the surface of water through which light from the bulb can emerge out? Refractive index of water is 1.33. Consider the bulb to be a point source. In fact, this type of problem has already appeared in examinations. Therefore, you have to remember this one. Right. First of all, let us try to understand the principle behind it. What is the physics principle which has been involved in this problem? Let us try to understand. Here is a tank, and this tank is containing water up to a depth of 80 centimeters. At the bottom, a source S has been placed, a point source. And once you consider point source, it gives out light in all directions. Let us consider a ray of light coming from the source and traveling perpendicular and incidenting on the surface normally. Already have the idea? This one travels without any deviation because it is normal incidence. But if you consider another ray of light incidenting at certain angle here, since it is traveling from denser medium to rarer medium, it bends away. And you can always consider a particular ray of light where the angle of incidence will be such that the refracted ray just grazes the surface. And for this to happen, basically, we will be considering the concept of critical angle. That is C or C itself, no problem. Angle of incidence for which in the present in the denser medium for which the refracted ray grazes the interface, that is angle of refraction becomes equal to 90, is what we are calling as critical angle. Okay, this happens. But any ray of light if you consider, okay, here it undergoes total internal reflection obeying the laws of reflection. And this will be taking place in all directions. Okay, but I cannot represent this one completely, but I can always consider another ray here also, which is all again incidenting here at an angle equal to critical angle, and this one will also be grazing the surface. Therefore, on the surface of water, we will be getting a circular patch of light. Only the rays traveling from here up to this will be emerging out. All other rays incidenting at a point other than this one will be incidenting at an angle greater than critical angle, and therefore it will be undergoing total internal reflection. Therefore, no question of light emerging out. Only up to this periphery, okay, light will be coming out. That's why we get a circular patch of line, and we have been asked to calculate the area of this. The area but for this one we can consider some radius. Let us consider the radius as, okay, I just avoid smaller because you may confuse this one with angle of refraction. Okay, that I am using capital R. For the height to which the medium is extending has been given as 80 centimeter. Therefore, this value is equal to h, and we have the job is to find out this area of this one. Okay, shaded portion area we have to find. You can work out this one in two ways. Directly, you can find out the area by remembering a formula. Otherwise, you can find out the critical angle corresponding to this mid water, and using that one, you can find out the radius, and thereby it is possible to find out the area. Okay, first I will discuss this method. Afterwards, I will give the simplified formula also, where directly you can find out area without going for critical angle. Okay, but once this angle is IC, you should understand that this angle will also be equal to IC, because this is what perpendicular, this is also a perpendicular to surface. That means these two are parallels. This is like acting like a transverse. Therefore, alternate angle. Okay, therefore, this is critical angle. This angle is also critical angle. Okay. Now, refractive index when you consider, especially for total interval reflection, we consider n is equal to sin IC. Okay, therefore, sin IC is equal to 1 by n. It is reciprocal of the refractive index of the medium will be giving the sign of the critical angle corresponding to the medium. Therefore, once you consider this is 1 by 1.3, because we have been given with the refractive index of what? 1.33. Okay, and this comes out to be 0.759. Okay, therefore, critical angle is sin inverse of 0.7519. Okay, 0.7519 is the one. Now, critical angle, if you calculate with the flat swing, it comes out to be 48 degree 45 minutes. So this is the value of the critical angle corresponding to this water of refractive index 1.3. Okay, but if I consider this as O, as this as some point P, from the triangle SOP, tan IC is equal to R divided by opposite by adjacent. Therefore, this implies R is equal to H into tan IC. Now, H, it is 80 centimeter into tan of 48 degree 45 minutes. The critical angle value that we have got. And this one, if we simplify, in fact, if I consider this one in SI system, we can always take this as 0.8 meter. Okay, and therefore in terms of meter, it will be 0.912 meter. Okay, I have written the simplified value of the radius. If I tan 48 degree 45 minutes, you have to find out. And on simplification, you will be getting 0.912 meter. But our job is to find out area. What is the formula for circular patch? It is pi r square. Therefore, 3.14 into 0.912 square. Simplification. Getting this will be equal to, okay, this will be equal to 2.612 meters square. 2.612 meters square is the area of the patch of light through which the light will be emerging. Okay, this is the first one. first method that you can adopt for finding out. In fact, sometimes they give or they'll ask you to calculate the critical angle and then area of the radius. In that case, you have to go through these steps only. Okay, problem paper setter ge correct idea idre ಇದನ್ನೇ ಕೊಡ್ತಾರೆ ಯಾಕಂದ್ರೆ ಮಾರ್ಕ್ಸ್ has to be distributed for 5 marks. The problem is ಹಾಗಾಗಿ ಆ 5 marks ನ distribution ಗೆ ಹೆಲ್ಪ್ ಆಗಲಿ ಅನ್ನೋದಾದ್ರೆ they will ask to find out critical angle and then only the radius and the area will be asked. ಹಾಗಾಗಿ ಈ ಮೆಥಡ್ ಜ್ಞಾಪಕ ಇರಲಿ. Okay, now I suggest the direct method without, and in fact it's better to remember the formula that I give now and it will be useful for competitive examinations. Okay, you can apply here also, no problem. If they are just as radius or the area, you can directly use. Okay, Adre, this is the basic idea that has been involved in this problem. Okay, now once you consider n, already you know it is equal to sin I by sin I. Okay, this is the thing. But this is the formula for the critical angle. But from tan IC, if I consider, already you know tan IC is equal to R by H. Radius divided by height. Therefore, R by H if I consider, and in fact, once it becomes equal to critical angle, okay, basically n will be equal to 1 over sin IC. Okay. This is the critical angle is equal to n is equal to 1 over sin IC. One formula that you remember, and then tan IC is equal to R by H. Therefore, R by H is equal to sin IC by cos IC. I'm deriving the formula. Okay. But cos IC, if I consider, it can be written as root of 1 minus sin square IC. Trigonometry. Okay, cos square theta is equal to 1 minus sin square theta. Therefore, cos theta is equal to root of 1 minus sin square theta. Now, I take sin x here to this and I will divide. In that case, I will take 1 divided by root of 1 by sin square IC minus 1. This is R by H. But just now I have given the formula. N is equal to 1 by sin IC here, 1 by sin square IC. Just I have taken this one into this. Otherwise, you can do one thing. Sin square IC can take common factor. Outside this one, sin IC cancels out. Therefore, we will be getting 1 over sin square IC minus 1. Okay. But this can be written as 1 by root of n square minus 1. Okay. Therefore, this is equal to 1 divided by root of sin square IC minus 1, which is equal to 1 by root of n square minus 1. Therefore, the formula for radius becomes h divided by root of n square minus 1. Therefore, if you have given refractive index, okay, directly you can substitute n value here and you can find out the radius. Directly you will be getting this value if you use this formula, and thereby you can easily find out the area also. You can use this formula also. So this is the second method. Remember the formula. Okay, definitely it will be useful. Usually, okay, smart martho confusion is there. Usually, method you can adapt and you can get the final answer. Therefore, now I discuss problem related to normal shift, then the problem related to total internal reflection. Okay, these two problems related to refraction at plane surface. Now let us consider some important problems related to prisms. Okay, that is refraction in case of prisms. And now we discuss that. If a monochromatic ray of light is made to incident on one of the refracting faces of the prism at an angle say I, it undergoes refraction, making an angle R1 at the first refracting surface, and it falls on the second refracting surface with an angle of incidence which can be represented as R2. And finally, the ray emerges out, and already have the idea, the bending will be towards the base. The ray bends towards the base. Okay, the bending has to be towards the base. In fact, here the ray is traveling from denser to rarer medium. Therefore, the bending has to be away from the normal. That means the ray bends towards the base, and this angle is what we are calling as angle of emergence. That is E. But during the derivation of the formula for the refractive index of the material of the prism, okay, in case of prisms, you will come across this. In fact, this total deviation, if you consider, okay, basically we will come across the formula during the derivation. That is angle of incidence plus angle of emergence minus A. Okay, R1 plus R2 will be getting. Okay, therefore, this is the one. And in fact, once we consider this D or the angle of incidence at a particular position, okay, once we consider this 1D, that is, if we want D to be D minimum, which we represent as capital D, for minimum deviation, okay, basically what happens is this I will be equal to A plus B by 2 and R will be equal to A by 2. Okay, this is only for minimum deviation position. Okay, you cannot use these two formulae for other cases. Okay, in general, total deviation is given by I angle of incidence plus angle of emergence minus A. Okay, and in fact, we should also know that angle of the prism is equal to R1 plus R2. Okay, that also you should be knowing. And already you know at minimum deviation position, the ray which will be traveling inside the prism will be traveling parallel to the base, so that the angle of incidence and angle of emergences will be same. That is I E. That is I will be equal to E. Whenever the angle of incidence, if it is equal to angle of emergence, basically the ray will be undergoing minimum deviation. Okay, and at minimum deviation position, basically the refracted ray inside the prism travels parallel to the base. That means the ray passes symmetrically. In fact, I am mentioning all these points just because instead of directly mentioning that the prism is in minimum deviation position, they may say simply the ray is traveling symmetrically. Okay, the refracted ray inside the lens prism is passing parallel to the base. Okay, if these words are there, it is clear the prism is in minimum deviation position. That is I is equal to E, R1 is equal to R2 is equal to R. Okay, and therefore we will come across minimum deviation, and this will be the formula corresponding to angle of incidence and angle of refraction. It is R. This R which I am considering here, that R will be equal to A2. Okay, these are the ideas that you should be knowing before working out problems And in fact, finally, n if you consider, it is general formula is by Snell's law sin I by sin r. But this will be equal to, okay, once I consider this, it is sin I by sin r. This will be equal to sin a plus b by 2 by sin a by 2. Okay, this you have to remember. These are all the formulas. If you remember these, you can work out any problem related to this. Okay. Now, first I will take up the problem which has appeared on July 14th or in July 14th question paper. It basically is there in July 14th question paper 2014 question paper. This is the third problem that I am discussing. Now, a prism of angle 60 degree produces angle of minimum deviation of 40 degree. What is the refractive index? Calculate the angle of incidence. A simple problem has been asked. Angle of the prism is 60 degree. Let us note on the data. A is equal to 60 degree. Angle of minimum deviation, already I mentioned, it is capital D, okay, which has been given as 40 degree. First we have been asked to calculate n, refractive index, and then angle of incidence corresponding to the minimum deviation. That you must understand. The prism is in minimum deviation position and angle of incidence when the ray is passing symmetrically has been asked to calculate. Now, just now I mentioned the formula n is equal to sin a plus b by 2 whole divided by sin a by 2. Okay, don't forget to write the formula. Sometimes, okay, what happens is the problem will be very easy. Okay, in such cases, what happens is you just start substituting the values without writing the formula. You will be using the mass. First, write the formula and then go for simplification. Substitute, show the substitution of sin. This is 60 degree plus 40 degree by 2 whole divided by sin 60 degree by 2. 60, 40, 100 divided by 2, that is sin 50 degree. And this is sin 30 degree. Sin 50 degree if we consider from Platt's table. It is 0.7660. Sin 30 already you know it is 0.5. Okay. Therefore, it comes out to be 1.532. This is the refractive index of the material of the prism. 1.532. Formula 1 marks, substitution, final answer 1 mark, 3 marks. But still we have to calculate one more, that is I. Angle of incidence at minimum deviation position already I mentioned. It is a plus b. Whatever way I have taken here itself is the angle of incidence. Okay, therefore a plus b 2. This is equal to is 60 degree plus 40 degree by 2, which is 50 degree. This is angle of incidence. Find out I. ಈ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರುತ್ತೆ ಆದರೆ ಇದರ I ಗಳನ್ನು ಮಾಡ್ಕೊಳ್ತಿರುತ್ತೆ ಅದಕ್ಕೋಸ್ಕರ ಇದು ಕೊಟ್ಟಿದ್ದಾರೆ ಅದರಲ್ಲಿ ಡೈರೆಕ್ಟ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ n but I is simply a plus d by 2. Therefore sin, that is angle of incidence, is 50 degree. That means the ray in this case is incidenting at 50 degree and it is undergoing a minimum deviation of 40 degree. That means you know the graph also. Okay, this is how we getting, and this angle is equal to 50 degree and the angle of minimum deviation here is 45 degree. Here is the deviation. Here is the we have taken I. Okay, graph ಹಾಕಿದ್ರೆ ಈ minima ಎಲ್ಲಿ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ it is coming out at 50 degree ನಲ್ಲಿ ಬರ್ತದೆ. This is the thing. Okay. Yes. Let us work out one more problem, okay, related to prism only. Again, it is examination problem, and this is from March 2017 question paper. March 17 question paper. Okay. Yes. Yes, I'll read the problem. A prism is made of glass of unknown refractive index. A parallel beam of light is incident on a face of the prism. The angle of minimum deviation is measured to be 40 degrees. What is the refractive index of the material of the prism? The refracting angle of the prism is 60 degree. That is, angle of the prism is 60 degree. If the prism is placed in water of refractive index 1.33, predict the new angle of minimum deviation. Okay. Therefore, again, two parts are there in the problem. You have to first of all find out the refractive index of the material of the prism using the first set of data. Afterwards, the whole prism is being immersed inside water, and corresponding to that system, for the same beam of light incidenting at same angle, what is the angle of minimum deviation? Okay, that you have to find. Okay, first of all, first part let us consider, where our job is to find out the refractive index of the prism. That is n of the prism. I have to find refractive index of the material of the prism. That's why I'm just using this P. Now, once you consider this, for this, A has been given, A is equal to 60 degree, and B has been given as 40 degree. Therefore, first problem is similar to the previous only. That is, refractive index of the material of the prism is equal to sin A plus B by 2 by sin A by 2. Therefore, it is sin 60 degree plus 40 degree by 2 whole divided by sin 60 degree by 2. Therefore, it is sin 50 degree by sin 30 degree. Already in the previous problem I have given this one is 0.7660, 0.5, and therefore 1.52. Okay, the first part. But in the second part, in addition to the prism whose refractive index is 1.54, we are considering water. It means the prism is now has been placed inside water. Okay, water very good. What will be it? Angle of minimum deviation equal to the refractive index 1.3. Critical angle, that is angle of minimum deviation, you have to find out. I am representing this as D dash. The new angle of minimum deviation at D dash, but A is again 60 degree only. No change in the angle of the prism. That variation. Okay. Prism na immerse ಮಾಡ್ತಲ್ಲ. But A ಅದೇ ಇದೆ. D dash has to be the new one. Okay. ಇಲ್ಲಿ ನೀವು observe ಮಾಡ್ತಿದ್ರೆ, here the light is traveling from A to the prism. ಹಾಗಾಗಿ we considered only the refractive index of the material of the prism with respect to air. But here it is traveling from water to prism. Therefore, in this case, you have to consider refractive index of the material of the prism by refractive index of the material of water. This has to be equal to sin A plus the new angle of deviation by sin A. Okay, if you can get this idea, okay, you'll be getting fine complete. It is refractive index of material of the prism by refractive index of water in which it has been immersed. Okay, that we have to consider. And D dash was already mentioned in the new angle of deviation. Okay. Now, already you know one NP is 1.532. This is 1.33, and this comes out to be 60 degree plus D dash to 5 sin 60 degree by 2. I'm showing the substitution. Okay. Therefore, it comes out to be 1.532 by 1.33. If we simplify, we get 1.15 is equal to sin 30 degree plus D dash by 2. Divided by sin 30. Therefore, sin 30 degree plus D dash by 2, 0.5 into this. Okay, and then it will be 0.2750. This is what we get. Therefore, 30 degree plus D dash by 2 comes out to be sin inverse of 0.5730. Okay, on simplification using Clark's table, you get this as 35 degree 6 minutes. Therefore, this is 30 degree plus D dash by 2. Therefore, D dash by 2 is 35 degree 6 minutes minus 30 degree, which is this is 5 degree 6 minutes, and this is D dash by 2. Therefore, D dash comes out to be 10 degree 12 minutes. So this is the new angle of minimum deviation which we have been asked. Problem is a little bit lengthy, but it has already appeared in one. It is March 2017. Therefore, always there will be greater probability. Okay, it's same values are with, and in fact, it is there in the textbook. Textbook problem has been taken in the question paper. Already noted. Yes. Now I want to the next. It is fifth problem, and this is from March 2020 question. Another important thing is this is also there in the textbook. Okay, textbook ಅಲ್ಲಿ ಇದೆ ಪ್ರಾಬ್ಲಮ್, ಹಾಗಾಗಿ ಅದನ್ನೇ ಪಿಕ್ ಮಾಡಿದ್ದಾರೆ. ಪ್ರೀವಿಯಸ್ ಯೂಶುವಲ್ ಆಗಿ ಹೇಳ್ತಲೇ ಇರುತ್ತೆ ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಅಥವಾ ಇದರಲ್ಲಿ worked examples and problems present in the exercise, especially the problems which can appear. NCERT book ಅಲ್ಲಿ ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ಸ್ ತುಂಬಾ ಲೆಂತ್ ಇದೆ, ಸೊಲ್ಯೂಷನ್ ಚಿಕ್ಕದಾಗಿದೆ, ಕೆಲವು ಸ್ಲಿಪ್ ಚಿಕ್ಕದಾಗಿದೆ ಪ್ರಾಬ್ಲಮ್, ತುಂಬಾ ಸೊಲ್ಯೂಷನ್ ಇದೆ, ಅಂಡ್ ಆ ತರದ ಪ್ರಾಬ್ಲಮ್ ಬರೋ ಚಾನ್ಸಸ್ ಕಮ್ಮಿ ಮೇನಿಗೆ. ಹಾಗಾಗಿ ಅದನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಬರಕ್ ಅವಕಾಶ ಇದೆ ಅವೆಲ್ಲವನ್ನು ಕೂಡ ನೀವು ನೋಡ್ಬೇಕು. ನೋಡಿ 2 ಸಲ ಕಂಟಿನ್ಯೂ ಇದು ಕೂಡ ಇದೇನಿತ್ತು, ಇದು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಇತ್ತು, ಅದನ್ನೇ ಹಂಗೆ ಪಿಕ್ ಮಾಡಿದ್ರು. ಈಗ ಈ ಪ್ರಾಬ್ಲಮ್ ಕೂಡ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾನೆ. ಇದು 20th ಕ್ವಶನ್ ಬೇಕಾ, 20 ಕ್ವಶನ್ ಬೇಕಾ, ಬಟ್ ಇಟ್ ಇಸ್ ದೇರ್ ಇನ್ ದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್. Okay, the problem is, at what angle should a ray of light be incident on the face of a person of refracting angle 60 degree so that it just suffers total internal reflection at the other face? The refractive index of the material of the prism is 1.524. Okay, this is the problem. First of all, you have to understand the problem. We have been asked to find out the angle of incidence that is required at the first face of the prism, whose refracting angle is 60 degree, and the ray must undergo total internal reflection at the other face. Innond face alli, okay, it has to undergo total internal reflection. That means it should not emerge out of the second refracting face. Already ಬರ್ಬೋದು. ಆ ಥರ ಆಗಬೇಕು ಅಂದ್ರೆ ಏನ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇರಬೇಕು? That is what we have been asked to do. But here, for working out this, first of all, let us consider the case where here is the prism and the angle is equal to 60 degree, angle of the prism. Now let us consider the angle of incidence such that here the angle is equal to critical angle. If the angle of incidence at the second refracting phase becomes equal to critical angle, then it raises the interface. And for this to happen, I is the angle of incidence. ಇದಕ್ಕಿಂತ ಬೇರೆ ಆಂಗಲ್ ಅಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿಸಿದ್ರೆ ಆಟೋಮೆಟಿಕಲಿ the ray will be incidenting on this one at an angle greater than critical angle. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಏನಾಗಿದೆ, R2 is equal to IC. But if we consider another angle here, R2 becomes greater than IC. Okay, and in this case, total internal reflection has to happen. ಹಾಗಾಗಿ ಇದು ಕೇಸ್, ಓಕೆ, ಥ್ರೆಶೋಲ್ಡ್ ಅಂದ್ರೆ ಆ ಲೆವೆಲ್ ಅಷ್ಟೇ. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ಟೋಟಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಟೋಟಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಹ್ಯಾಪನ್ಸ್ ಫಾರ್ ಆಲ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸಸ್ ಅಟ್ ದಿ ಸರ್ಫೇಸ್ ವಿಚ್ ಇಸ್ ಗ್ರೇಟರ್ ದನ್ ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್. ಹಾಗಾಗಿ ಇದು ಕೇಸ್ ನ ತಗೊಳ್ತಾ ಇದ್ವಿ. ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಅಂಡರ್ಗೋಯಿಂಗ್ ಟೋಟಲ್ ರಿಫ್ಲೆಕ್ಷನ್. ಹಾಗಾಗಿ ಈ ಐಗಿಂತ ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಅದಕ್ಕಿಂತ ಒಂಚೂರು ಬೇರೆ ಇದ್ದು ಸಾಕು, immediately the ray will not emerge out of this. It in fact it undergoes total internal reflection. Okay, ಅಥವಾ ಇದೇ ಪ್ರಾಬ್ಲಮ್ ನಿಮಗೆ one angle of incidence for which the ray the refracted ray at the second surface raises the interface ಅಂದ್ರೆ ಇದನ್ನ ಐ ಕಂಡುಹಿಡಿಯಬೇಕು. ಆದ್ರೆ ಇದನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಆಂಗಲ್ ಅಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿಸಿದ್ರೆ ಆಟೋಮೆಟಿಕಲಿ there will be no. Okay, ಹಾಗಾಗಿ ಇಲ್ಲಿ ನಿಮಗೆ ಅದು ಅರ್ಥ ಆಗಬೇಕು. ಆದ್ರೆ ಇದು R1 ಹಾಗೆ ಇದೆ, but R2 in this case is equal to critical angle. Okay, ಇದು ಕೇಸ್. ಆದ್ರೆ ಟೋಟಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಈಗಿಂತ ಬೇರೆ ಅಂದ್ರೆ ಹೈಯರ್ ಆಂಗಲ್ ಅಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಬೇಕು. ದಟ್ ಇಸ್ ದ ಪಾಯಿಂಟ್. ಅಷ್ಟೇ. ಹಾಗಾದ್ರೆ ನಾವು ಐನ ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂಡು ಬಂದ್ರೆ ಇಲ್ಲಿ ಬೇರೆ ಆಗುತ್ತೆ, ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. In that case, basically R2 becomes greater than critical angle, therefore total reflection happens. ಹಾಗಾಗಿ ಥ್ರೆಶೋಲ್ಡ್ ಜಸ್ಟ್ ಕ್ರಿಟಿಕಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಏನಿದೆ ಅಂತ ನೋಡ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ. ಆ ಕಂಡೀಷನ್ ಇಟ್ಕೊಂಡು ನಾವು ಐನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ಅಂಡರ್ಗೋಸ್ ಟೋಟಲ್ ರಿಫ್ಲೆಕ್ಷನ್. ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಿ. ಕೆಲಸ ಏನ್ ಮಾಡ್ತಾರೆ, the ray of light incidenting along the normal to the first surface itself. Along the normal ಬಂದ್ಬಿಡ್ತು ನಮಗೆ I becomes equal to 0. I 0 ಆದಾಗ R1 ಕೂಡ 0 ಆಗುತ್ತೆ. ಆದರೆ R2 will be there. Okay, from R2 here. Okay, ಹಾಗಾಗಿ ನಾರ್ಮಲ್ ಇನ್ಸಿಡೆನ್ಸ್ ಏನಾದ್ರು ಕೇಳ್ತಾರೆ ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿಲ್ಲ ಇಲ್ಲಿ, ಬಟ್ ಜಸ್ಟ್ ಐ ಮೆನ್ಷನ್ ಅಕಸ್ಮಾತ್ ಆ ಥರದ್ದು ಇದನ್ನು ಕೇಳ್ತೀವಿ, ನಿಮಗೆ ಫೇಸ್ ಆಗುತ್ತೆ ಏನಾಗುತ್ತೆ. ಓಕೆ, ಅವಾಗ ಕೂಡ ನಿಮಗೆ ಗೊತ್ತಾಗಬೇಕು ಇಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು. ಇದು ಗೊತ್ತಾದ್ರೆ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ವರ್ಕೌಟ್ ದಿಸ್ ಆಲ್ಸೋ. ಓಕೆ, ಇದನ್ನು ವರ್ಕೌಟ್ ಮಾಡೋದಕ್ಕೆ since we know A, I they have been asked to calculate. R1 we don't know, R2 which is IC also we don't know. Adre, they have given the refractive index of the material of the prism and the value has been given as 1.524. Okay, this critical angle sorry, refractive index is 1.524. This is the value of the angle of incidence. Sorry, refractive index they are given. Therefore, using the idea of total reflection, sin IC is equal to 1 by E. Therefore, it is 1 by 1.524. Okay, and 1.1 divided by 1.524 comes out to be 0.6562. 0.6562 is the value get. This is sin of the critical angle. Therefore, critical angle is sin inverse of 0.6562. This is 41 degree. The critical angle is equal to 41 degree. This is the value we get. But already mentioned, during refraction in case of prisms, A will be equal to R1 plus R2. Already I have given the idea here R2 will be equal to IC. Therefore, this is R1 plus IC. Just now we have calculated IC. Therefore, from this one R1 becomes equal to A minus IC. Critical angle, which is 60 degree minus 41 degree, which is 90 degree. This is the angle of refraction at the first surface. First surface is angle of incidence. For angle of refraction, that we have calculated. We can calculate this and by using this formula. Okay, the R1 is equal. But at the first surface, at first phase, let's say n is equal to sin I by sin R1. Okay, sin I by sin R1. Again, sin I is equal to n into sin R1. N is 1.524 into sin 90 degree. Okay. This is 1.524 into 0.3256. This comes out to be 0.4962. Therefore, I becomes equal. This is only the value of sin. Therefore, I becomes equal to sin inverse of 0.4962. The value is 29 degree 45. This is angle of incidence. For this, it just grazes the surface, and if the angle of incidence becomes more than this, even a slight increase in the angle of incidence makes the ray to undergo total reflection. Total reflection around the node. Okay, this is the angle of incidence above which total reflection happens. Okay, total reflection now just the angle we are considering. Grace one. Two ways it comes back to the same medium. 100% light comes back to the same medium. This is from March 2020 question paper. These are the three different types of problems which have appeared related to prisms. Prisms is problems. ಎಲ್ಲ ಫಾರ್ಮುಲಾನು ಯೂಸ್ ಮಾಡಲಾಗ್ತದೆ. ಹಾಗಾಗಿ ಬೇರೆ ಏನೋ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟರು ಇದೇ ತರ ಐಡಿಯಾ ಅಂತ ಮಾಡ್ಬೇಕು ಅಷ್ಟೇ ತಡೆದದ್ದು. Yes. Now, I start discussing problems related to refraction at spherical surfaces, okay, including lenses. Lenses of spherical surface. Idana refraction related problems I will discuss. First, let us consider the problems related to just refraction at spherical surfaces. Already you know, if you consider a surface which is part of a sphere, we call it a spherical surface. Since there is the spherical surface, and if an object is placed at certain distance u, then the rays traveling along the principal axis corresponding to the refractory surface travels without any deviation. This is the whole of the refracting surface, the geometric center. But if you consider another way of it, here, okay, incident in such an angle, in fact, the center of curvature is here. This will be the normal corresponding to this point of incidence, and instead of traveling with this, it bends, therefore it goes and meets the ray traveling along the principal axis at some point. There we get, here we get the image. Okay, if this is N1 and this surface is having refractive index, there is radius of curvature R, it means this distance is R, and this is basically the position of the image, and I am considering this as B. And this medium is having refractive index here. Okay, already you know the general formula for the refraction of the spherical surface, that is N1 by minus U plus N2 by V is equal to N2 minus N1 by R. This is the general formula for the refraction light that is taking place at any spherical surface. But while we're deriving it, we have used sign conventions, Cartesian sign conventions. You will observe since it is considering the refraction at spherical surface, all distances must be measured from the pole and along the principal axis. But this is the direction of the incident light. Okay, direction of incident. And once you consider this u, now to measure it, we have to move from pole to this. But our direction of measurement will be opposite to this. Therefore, this u will be negative. Okay, u negative agutte. And when you consider the distance between the pole and the center of curvature, we call it as radius of curvature. Since the surface is like this, the measurement is in the direction of the incident light itself. Therefore, R will be positive. And again, when you come to the position of the image, the distance is from here to here. Again, the direction of measurement is same as the direction of the incident light. Therefore, V will also be positive. Therefore, the idea of sign convention is very important. And even though you have used the sign conventions while deriving the formula, in theory, while working out the problems, again you have to apply Cartesian sign convention. This you have to remember. You have to apply it again. Alagle madidalla anta direct agi substitution madakoodu. Dirgha sign convention hakollebeku. Okay, this is the important idea you have to remember. Okay, First, let us just consider the problems related to refraction at spherical surface. ಅದೊಂದನ್ನೇ ತಗೊಳ್ಳೋಣ. ಅದಾದ್ಮೇಲೆ next one ಗೆ ಹೋಗೋಣ. The sixth problem that I am discussing now. Light from a point source in A falls on a spherical glass surface of refractive index 1.5 and radius of curvature 20. The distance of the light source from the glass surface is 100 centimeter. At what position the image is formed? They have given just the spherical glass surface. It is not a complete sphere. Okay, problem ಅದುವಾಗ ಸ್ವಲ್ಪ ಹುಷಾರಾಗಿ. Spherical surface ಇದೆ ಅಷ್ಟೇ, ಸ್ಪಿಯರ್ ಅಲ್ಲ. ಸ್ಪಿಯರ್ ಆಗ್ಬಿಟ್ರೆ ಅದು ಎರಡನೇ ಸರಿ ಕೂಡ ರಿಫ್ರಾಕ್ಷನ್ ಆಗೋ ಪರಿಸ್ಥಿತಿ ಬರುತ್ತೆ. ಆದರೆ ಇಲ್ಲಿ there is no such question. There is no question of second refraction. Only one time it undergoes refraction and we will be getting the image inside the glass. Okay, glass ಒಳಗಡೆ ಬಂದಿರುತ್ತೆ image. ಅದರ ಪೊಸಿಷನ್ ಕಂಡುಹಿಡಿಯಿರಿ. ಅಂದ್ರೆ whatever diagram that I have shown is similar to that one only. In fact, a point source has been placed. Okay, and this u they have given, and this u is equal to 100 centimeter. 100 centimeter the quote. And sign convention clearly gives the idea. This is minus. Okay, u ಅಂತ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, that is minus 100 centimeter. Okay, ಇಲ್ಲಿಂದ radius of curvature also they have given. It is 20 centimeter. ಹಾಗಾಗಿ r equals plus 20 centimeter. Okay, r ಕೂಡ plus positive. We have been asked to find out v. v ನ ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಅಷ್ಟೇ. v is 2. Okay, where actually we get the image. But refractive index outside is a. ಹಾಗಾಗಿ n1 is equal to 1 ಆಗ್ತದೆ, n2 will be equal to 1. Okay, 1.5 ಆಯ್ತು. ಹಾಗೆ ಇಷ್ಟು ಐಡಿಯಾ ಇದ್ಬಿಟ್ರೆ ನಾವು ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ವರ್ಕ್ ಔಟ್ ದಿಸ್. ಏನು n1 ಜಾಗದಲ್ಲಿ ಏನಾಗ್ತೀರಾ, ಮೈನಸ್ 100. ಇಲ್ಲ ಅದಕ್ಕೆ ಹೇಳಿ ಮೈನಸ್ ಇತ್ತು ತಿರ್ಗಾ ಹಾಕೋಬೇಕು, ಮರಿದಲ್ಲೇ ಹಾಕ್ಬೇಕು. ಪ್ಲಸ್ n2 is 1.5 by v. v. ಓಕೆ, ಅದು ಪ್ಲಸ್ ಮೈನಸ್ ಅದು ಆಮೇಲೆ ಆನ್ಸರ್ ಕಂಡಿದ್ದಾಗೆ ಗೊತ್ತಾಗುತ್ತೆ. This is 1.5 minus 1 divided by 20. 1 by 100 ಅಂತ ಹೇಳಿದ್ರೆ ಇದು 0.01 plus 1.5 by b. This is 0.5 divided by 20. Okay, let's simplify ಮಾಡ್ತಾರೆ. For 1.5 by b becomes equal to 0.5 by 20 ಅಂತ ನಾವು ತಗೊಂಡ್ರೆ 0.025 ಆಗುತ್ತೆ. ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಬೇಕಾದ್ರೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ minus 0.01. So this works out to be 0.15. We are not converted distances into meter. ಅದಕ್ಕೆ ಜ್ಞಾಪಕ ಇರಲಿ, ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲೇ ತಗೊಂಡಿದೀವಿ, ಹಾಗಾಗಿ ಫೈನಲ್ ಆನ್ಸರ್ ಸೆಂಟಿಮೀಟರ್ ಬರುತ್ತೆ. ಮೀಟರ್ ಕನ್ವರ್ಷನ್ ಮಾಡಿದ್ರೆ you will get it in meters. Therefore this is only 1.5 by b. Therefore v is 1.5 divided by 0.015. Even this comes out to be 100 centimeter. That means the image is formed at 100 centimeter. 100 centimeter nalle image formed. The object distance is simply equal to image distance. With respect to this pole is same. Okay, this is happening because of the value of the refractive index. radius of curvature and object distance that we are considering. Okay, values ಕೊಟ್ಟಿದ್ದಾರೆ ಈಸಿಯಾಗಿ ಸಿಂಪ್ಲಿಫೈ ಆಗುತ್ತರ. Therefore, my image is produced at 100 centimeter from this surface, okay, inside the glass ಒಳಗಡೆ image part. Thank you. Okay, this is problem. Now, let us come to the problems related to the lenses. Okay, idea is that idrinde neevu yadike ಎಷ್ಟು ಬೇಕಾದರೂ problem workout ಮಾಡಬಹುದು. Any number of problems, whatever problem they ask, just use the idea, use the same dimensions. Okay, you will be getting the final answer. Okay, ಯಾವುದು ಕೇಳಿದ್ರು ಕೂಡ workout ಆಗುತ್ತೆ. Now, let us move on to lenses. First, I am considering problem related to lens makers formula. Lens makers formula the problems ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. And in fact, most of the problems are related to this one. Okay, ನಿಮಗೆ ಗೊತ್ತಿದೆ already. Ray optics ಅಲ್ಲಿ theory question ಬಂತು ಅಂದ್ರೆ wave optics ಅಲ್ಲಿ problem. ಅದು wave optics ಅಲ್ಲಿ theory question ಕೊಟ್ಟಿದ್ದ ವರ್ಷ ಎಲ್ಲ ray optics ಅಲ್ಲಿ problem ಬಂದಿದೆ. ಆದರೆ ವೇವ್ ಆಪ್ಟಿಕ್ಸ್ ಪ್ರಾಬ್ಲಮ್ ಬಂದಿರೋದೇ ಜಾಸ್ತಿ. ಹಾಗಾಗಿ ರೇ ಆಪ್ಟಿಕ್ಸ್ ನಿಮ್ದು ಎಕ್ಸಾಮಿನೇಷನ್ ಪ್ರಾಬ್ಲಮ್ ಅಂತ ತಗೊಳಕ್ ಕೊಟ್ರೆ ತುಂಬಾ ಕಮ್ಮಿ ಇದೆ. ಅದೇ ನೀವು ವೇವ್ ಆಪ್ಟಿಕ್ಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ತಗೊಂಡ್ರೆ ಯಂಗ್ಸ್ ಡಬಲ್ ಸ್ಲಿಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮೇಲೆ ವೆರೈಟಿ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆರ್ ದೇರ್ ಇನ್ ಕ್ವಶನ್ ಪೇಪರ್ಸ್. ಹಾಗಾಗಿ ಸ್ವಲ್ಪ ಅದು ಇರಬೇಕು ನಿಮ್ಮ ಇದು ಪೇಪರ್ಸ್ ನಿಮಗೆ ಸಿಗೋ ಪೇಪರ್ ಅಲ್ಲಿ ಯಾವ್ದು ಪ್ರಾಬ್ಲಮ್ ಬಂದಿರುತ್ತೋ ಅಥವಾ ಯಾವ್ದು ಯಾವುದು. ಹಾಗಾಗಿ ಯು ಶುಡ್ ಬಿ ನೋಯಿಂಗ್. ಆದ್ರೆ ಇವೆರಡು ಚಾಪ್ಟರ್ ಪ್ರಾಬ್ಲಮ್ ಕ್ಲಿಯರ್ ಆದ್ರೆ if you know, okay, definitely you can get one problem, one guarantee workout ಮಾಡಕ್ಕೆ ಚಾನ್ಸ್. ಅದು ವೇವ್ ಆಪ್ಟಿಕ್ಸ್ ಆಲ್ರೆಡಿ ನಿಮ್ಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ ನಾನು ಆಗ್ಲೇ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೀನಿ, ಯಂಗ್ಸ್ ಡಬಲ್ ಸ್ಲಿಟ್ ಮೇಲೆ ಜಾಸ್ತಿ ಅದರಲ್ಲಿ ಇರೋದೇ ಒಂದು ಫಾರ್ಮ್. ಓಕೆ, ಹಾಗಾಗಿ ಆಮೇಲೆ ಜೊತೆಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಅದರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಬರ್ತದೆ. ಆದ್ರೆ ಇಲ್ಲಿ ವೆರೈಟಿ ಇರೋದ್ರಿಂದ ಎಲ್ಲ ವೆರೈಟಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡ್ಕೊಂಡ್ರೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ you have to learn the problems. Okay, now double convex lenses are to be manufactured. Okay, before that I mentioned the lens makers formula. 1 by f is equal to n minus 1 into 1 over r1 minus 1 over r2. This is when lens is in air. Lens ಏನಾದ್ರು air ಅಲ್ಲಿ ಇದ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಉಪಯೋಗಿಸಬೇಕು. Lens in some other medium, ಇನ್ಯಾವುದೋ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಇಟ್ಟಿದ್ದೀವಿ ಅನ್ನೋದಾದ್ರೆ ಏರ್ ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೇ ಮೀಡಿಯಾ ಆಗಿದ್ರು ಕೂಡ 1 by f focal length in the medium will be equal to lens refractive index of the lens, refractive index of the material of the medium minus 1 into 1 over r1 minus 1 over r2. ಇದಕ್ಕೆ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ ಇದು ಗ್ಲಾಸ್ ಆಗಿರುತ್ತೆ ಯೂಶುವಲಿ, ಹಾಗಾಗಿ NG ಅಂತಾನೆ ಇಟ್ಕೊಂಡ್ರೆ ಅದು ಬೇರೆ ಲಿಕ್ವಿಡ್ ಲೆನ್ಸ್ ಅಂತ ಆದ್ರೆ ಅವಾಗ ಬೇರೆ ಚೇಂಜ್ ಮಾಡ್ತೀವಿ ಅಷ್ಟೇ. ಹಾಗಾಗಿ NG by NM. ಓಕೆ, ಎನಿ ಅದರ್ ಮೀಡಿಯಂ. ಓಕೆ, ಅದು ವಾಟರ್ ಆದ್ರೆ ವಾಟರ್ ತಗೊಳ್ತೀರಾ, ಇನ್ಯಾವುದೋ ಲಿಕ್ವಿಡ್ ಆದರೆ ಲಿಕ್ವಿಡ್. Therefore, these are the two formulae related to lens makers formula you may get. Okay, ಈಗ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. A double convex lenses are to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. ಎರಡು ಸರ್ಫೇಸಸ್ ಸೇಮ್ ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಇರುತ್ತೆ. What is the radius of what is the radius of curvature required? If the focal length is to be 20 centimeter, focal length 20 centimeter ಇರೋದಾದ್ರೆ ಓಕೆ, ಇದು ಎಷ್ಟು ಬೇಕು? ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಆಫ್ ದ ಟೂ ಸರ್ಫೇಸಸ್ ಮಸ್ಟ್ ಬಿ ಸೇಮ್. ಓಕೆ, ಅದು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. For that, let us now know data. This is 7th problem. I am discussing double convex lenses. Okay, write the diagram so that you can easily understand this. ಈ ಸರ್ಫೇಸ್ ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ r1 ಅನ್ಕೊಳ್ಳೋಣ, ಇದ್ರದ್ದು r2 ಅಂತ. ನಾವು ಯೂಶುವಲ್ ಆಗಿ ಲೈಟ್ ಈ ಕಡೆಯಿಂದ ಕಳಿಸ್ತಾ ಇರ್ತೀವಿ, ಇದು ಡೈರೆಕ್ಷನ್ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್. ಹಾಗೆ ತಗೊಂಡಾಗ ಈ r1 ಅನ್ನೋದು ಏನಾಗುತ್ತೆ, r ಅಂತ ತಗೊಂಡಿದೀವಿ ಅದು ಪಾಸಿಟಿವ್ ಆಗಿಬಿಡುತ್ತೆ. ಆದ್ರೆ ಇಲ್ಲಿ r2 ಕೂಡ r ಅಷ್ಟೇ ವ್ಯಾಲ್ಯೂ ಇರಬೇಕು, ಆದ್ರೆ ಇದು ನೆಗೆಟಿವ್ ಇರಬೇಕು. ಹಾಗಾಗಿ ಒಂದು ಕೆಲಸ ಮಾಡೋಣ, ಡೈರೆಕ್ಟ್ ಸೈನ್ ಬರೀತೀನಿ. r1 is equal to less r ಆಗಿದೆ, r2 is equal to minus r. That is radius of curvature of the second surface. Magnitude wise same, but because of the Cartesian sign convention, the sign is different. Okay, that is minus r. Refractive index they have given in the class, okay, which has been used, and it is 1.5. Okay, focal length also they have given in air, you can say fa, focal length in air, and this is 20 centimeters. Okay, if you want you can take this one in meters. So meter better the half of it from meter. Now let us simplify this one. ಇಲ್ಲ ನೀವು ಪೆನ್ನಿಗೆ ಸೆಂಟಿಮೀಟರ್ ಲೆವೆಲ್ಸ್ ಕಳ್ತೀರಿ ಅಂದ್ರೆ ಉಳಿಸ್ತೀವಿ, ತೊಂದರೆ ಇಲ್ಲ. ಹಾಗೆ ಈಗ 1/fa is equal to ng minus 1 into 1 over r minus 1 over r2. This is the general formula. Okay, ಈಗ ಇಲ್ಲಿ ತಗೊಂಡ್ರೆ 1/20 ಆಯಿತು equal to 1.55 minus 1 into ಯಾಕೆ ಅದಕ್ಕೆ ಬರುತ್ತೆ ಈಸಿ ಎಕ್ಸಪ್ರೆಷನ್ ಮಾಡಿದ್ರೆ 1/r minus 1/minus. Therefore this is 1/20 and this is 0.55. This is 2/r. Okay, 2/r. ಒಂದು ಮ್ಯಾಪ್ಕೆಟ್ ಕೊಡಿ, ಎರಡರದ್ದು ಸರ್ಫೇಸಸ್ ರೇಡಿಯಸ್ ಕರ್ವೇಚರ್ ಸೇಮ್ ಆದ್ರೆ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಅಂತ ತಕ್ಷಣ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ಪ್ರಕಾರ ಸೈನ್ ಇಂದಾಗಿದ್ದ 1 over fa is simply equal to ng minus 1 into 2/r. Okay, ಈ ಫಾರ್ಮುಲಾ ಡೈರೆಕ್ಟ್ ಆಗಿ ಮ್ಯಾಪ್ಕೆಟ್ ಕೊಡೋದು ಕೂಡ ಬರ್ತದೆ. Since the two surfaces are of radius of curvature same, this is the formula that you get. Okay, again here r in ಕೇಳಿರೋದು ಅಷ್ಟೇ. Therefore r is equal to 20 into 0.55. If you simplify, we get this one as 22. Radius of curvature of two surfaces which are to be identical is 22 centimeters. 22 centimeters on itಕೊಂಡಿದ್ರೆ then we will be getting the length of focal length 20 centimeters. For this refractive index ಏನಾದ್ರು ಚೇಂಜ್ ಆಯ್ತು ಅಂದ್ರೆ we will be getting some other. ಈಗ ನೋಡಿ 1.5 ಆಗಿದೆ, ಇಲ್ಲಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಇದು ಬರೀ 0.5 ಆಗಿದೆ. 0.5 into 10 ಏನಂದ್ರೆ ಬರೀ 10 ಆಗಿದೆ. 10 to 20. Okay, focal length ಇದು 10. ಹಾಗಾಗಿ ನೋಡಿ ಇಲ್ಲಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ 0.5 1.5 into 1 ಆಗುತ್ತೆ, 0.5 into 2 1 ಆಗುತ್ತೆ, r is equal to f. ಹಾಗಾಗಿ ng 1.5 ಆದ್ರೆ ಮ್ಯಾಪ್ ಇಟ್ಕೊಂಡು ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಫೋಕಲ್ ಲೆಂತ್ ಈಕ್ವಲ್ ಇರುತ್ತೆ. ಓಕೆ, ಈಕ್ವಿ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಆಗಿದ್ದು ng 1.5 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದ್ರೆ r equals fa. Okay, these are all the shortcuts which you have to remember for competitive examinations. ಅದಕ್ಕೋಸ್ಕರ ಬೇಕು ಅಷ್ಟೇ. ಬಿಫೋರ್ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರಲಿ, ಈ ಐಡಿಯಾ ಅವಾಗ ಬರುತ್ತೆ. ng 1.5 ಅಂತ ಆದಾಗ this is what you get. Okay, this is the 7th problem. I will discuss one more problem related to this one only. Yes. Eighth problem. In fact, three different parts are there. This one is textbook problem. And then the textbook. Eighth one. First part. If f is equal to 0.5 meter for a glass lens, what is the power of the lens? Okay. Focal length in air has been given as 0.5 meter, and we have to calculate the power. This is the first part of the problem. The second part, the radius of curvature of the two surfaces of the double convex lens are 10 centimeter R1, and it has to be positive. Already you know. Okay, one lens ಅಂತ ತಗೊಂಡ ತಕ್ಷಣ ಇದು ಪ್ಲಸ್ ಆಗಿರುತ್ತೆ, ಇದು ಮೈನಸ್ ಆಗಿರುತ್ತೆ. Okay, ಹಾಗಾಗಿ ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಟ್ಲಿ I am considering. Second value they are given is 15 centimeter. R2 is equal to minus 15 centimeter. Its focal length is, okay, this is a different lens. Focal length is 12 centimeter. What is the refractive index of glass? Okay, that is n of glass they have asked. Okay, focal length ಅಷ್ಟೇ ಕೊಟ್ಟರು. ಇಲ್ಲಿ focal length in air ಕೊಟ್ಟಿದ್ದಾರೆ, glass refractive index ನ ಕೇಳಿದ್ದಾರೆ. Third important one. Okay, a convex lens has 20 centimeter focal length in air. What is the focal length in water? Given refractive index of water 1.33 and refractive index of glass 1.5. ಹಾಗಾಗಿ ಮೂರು ಎಲ್ಲ ಅಡ್ಜಸ್ಟ್ಗಳನ್ನ ಸೇರಿಸಿ ಒಂದೇ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ತಿರುತ್ತೆ. ಬಟ್ ಸ್ಟಿಲ್ ಇಟ್ ಇಸ್ ಸಪರೇಟ್ಲಿ ಯು ಕ್ಯಾನ್ ಗೆಟ್. ನೋಡಿ, ಇದೇ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಅಷ್ಟೇ ತಗೊಂಡ್ರೆ 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ಬೋದು. ಯು ನೋ ದಿ ಪವರ್ ಆಫ್ ದ ಲೆನ್ಸ್ is there will be equal to reciprocal of the focal. But here you have to be very careful. Focal length has to be taken only in SI system. Centimeter ಕೊಟ್ಟಿದ್ರು SI ಗೆ ಕನ್ವರ್ಷನ್ ಮಾಡ್ಕೊಂಡು ಆಮೇಲೆ ರೆಸಿಪ್ರೋಕಲ್ ಹೋಗ್ಬೇಕು. ಆದ್ರೆ ಇಲ್ಲಿ ನಿಮಗೆ ಅದು ಈಸಿ ಮಾಡಿದ್ರೆ 1/0.5 and this comes out to be, okay, that is 0.5 ಅಂತ ಹೇಳ್ತಿದ್ರೆ ಹಾಕ್ತಾರೆ. ಹಾಗಾಗಿ you will be getting 2 diameter or diameter. 2D is the power of the lens. 1 marking ಅಥವಾ 2 marking ಕೇಳೋ ಚಾನ್ಸ್ ಇರುವಂತ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಆಫ್ ದಿ. second part already I have given data. Okay, third one ನಾನು ಹೆಂಗೆ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ. ಈ ಸೆಕೆಂಡ್ ಒನ್ ಈ ವರ್ಕೌಟ್ ಮಾಡಿ, ಯಾಕಂದ್ರೆ ಇದೇ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಆಗಲ್ಲ. ಹಾಗಾಗಿ ಸೆಕೆಂಡ್ ಪಾರ್ಟ್ ನ ಸಪರೇಟ್ ಏನಿದೆ. ಸೆಕೆಂಡ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ the radius of curvature of the faces of a double convex lens are 10 centimeter and 15 centimeter. Focal length is 12 centimeter. What is the refractive index of glass? ಅದರಲ್ಲಿ ಇನ್ನೊಂದು ನೀವು ತುಂಬಾ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕಾಗಿದ್ದು, ಕೊಟ್ಟಿರೋ ಲೆನ್ಸ್ ಯಾವುದು ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಹಾಗಾಗಿ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. ಅಕಸ್ಮಾತ್ ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಗೆ ಇದೇ ಪ್ರಾಬ್ಲಮ್ ಕೇಳ್ತು ಅಂದ್ರೆ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ವ್ಯತ್ಯಾಸ ಆಗುತ್ತೆ, ಅದನ್ನು ಕೂಡ ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿದ್ದೀನಿ. ಹಿಂಗ್ ಕೊಟ್ಟರು ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಫಸ್ಟ್ ನೀವು ಸರ್ಫೇಸಿಂಗ್ ನೋಡಿದ್ರೆ ಹೀಗೆ ಮೆಜರ್ ಮಾಡ್ತೀರಾ. ಹಾಗಾಗಿ R1 ನೆಗೆಟಿವ್ ತಗೊಳ್ತೀರಾ, R2 ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ನೋಡಿ, F ನೆಗೆಟಿವ್ ಇರುತ್ತೆ. ಓಕೆ, ಇದು ಕೂಡ ಗೊತ್ತಿರಲಿ. ಕೇಳೇ ಇರಲ್ಲ ಅಂತಂದ್ರೆ ಕೇಳಬಾರ್ದು ಅಂತ ಇಲ್ವಲ್ಲ. ಪೇಪರ್ ಸೆಟ್ ಕ್ಯಾನ್ ಬಿ ಫೋಕಲ್ ಲೆಂತ್ ನೆಗೆಟಿವ್ ಆಗಬೇಕು, R1 ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, R2 ಪಾಸಿಟಿವ್. ಇಲ್ಲಿ ತಗೊಂಡಾಗ F ಪಾಸಿಟಿವ್ ಇದೆ, R1 ಪಾಸಿಟಿವ್ ಇದೆ, R2 ನೆಗೆಟಿವ್ ಆಗಿದೆ. ಆದ್ರೆ ಇಲ್ಲಿ R2 ಪಾಸಿಟಿವ್, R1 ನೆಗೆಟಿವ್, ಬಟ್ F ಇಸ್ ನೆಗೆಟಿವ್. ಓಕೆ, ಹಾಗಾಗಿ ಇದು ಐಡಿಯಾ ಕೂಡ ಇರುತ್ತೆ. ಅದ್ರ ಕಾನ್ವೆಕ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಈಗ ಇದಕ್ಕೆ ಬಂದ್ಬಿಡುತ್ತೆ 1/FA is equal to Ng minus 1 into 1/R1 minus 1/R2 general formula. Okay, ಈಗ focal length in A ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರೇ 1/12 is equal to refractive index ಕಂಡುಹಿಡಿಯಲು ಕೇಳಿದ್ದಾರೆ. ಹಾಗಾಗಿ n g minus 1 into whole square into 1 over r1 1/10 minus of minus ಆಗುತ್ತೆ plus ಆಗುತ್ತೆ ಹಾಗಾಗಿ plus 1/15. ಓಕೆ ಅದನ್ನು ಜ್ಞಾಪಕ 1/12 is equal to ng minus 1. Observe ಮಾಡಿದ್ರೆ ಇದು 15 plus 10 ಇದು 10 into 15 ಓಕೆ ಹಾಗಾಗಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು ng minus 1 ಅಂತ ಅಂತಂದ್ರೆ this becomes equal to ಇದಲ್ಲ ಇದೆ ಇದು ಇಲ್ಲಿ ಹೋಯ್ತು ಅಂದ್ರೆ 10 into 15 ಅಂತ ಆಯ್ತು. ಇದು 12 ಇದು 25 ಹಾಗೆ ಕೆಳಗಡೆ ಏನು ಬಂತು 12 into 25 5 2s 5 5s 5 1s 5 3s ಹಾಗಾಗಿ 6 divided by 2 ಅಂತಂದ್ರೆ 0.5 ಆಯ್ತು. therefore ng minus 1 is equal to 0.5. therefore ng is equal to 1.5. ಇದು ಬೇರೆ ಲೆನ್ಸ್ ಇದೇ ಬೇರೆ ಲೆನ್ಸ್ ಅದರ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಇದನ್ನ ಇಲ್ಲಿ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಸಿಕ್ಕಿರೋದು ಎಷ್ಟು ನಮಗೆ 1.5. I hope you have understood up to this one. ಕ್ಯಾಲ್ಕ್ ತಗೊಂಡು ಸಬ್ಟ್ರಾಕ್ಷನ್ ಮಾಡ್ತು LCM ತಗೊಂಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ದೀನಿ and don't forget to consider the sign convention. ಮಿಸ್ ಆಗಿ ಮೈನಸ್ ಅನ್ನೋದು ತಗೊಳ್ತು ಅಂದ್ರೆ you will be getting different value. You will be losing marks. ಅದಾಗದು ಬೇಡ ವೆರಿ ಕರೆಕ್ಟ್ ಆಗಿ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. ಅದರ ಥರ್ಡ್ ಪಾರ್ಟ್ ಇದೆ ಏನಿದೆ a convex lens has 20 centimeter focus. Okay, take the screenshot. एक प्रॉब्लम है ಇದರಲ್ಲಿ ಥರ್ಡ್ ಪಾರ್ಟ್ ಎಲ್ಲ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ ಇದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಆಗಿ ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೂಡ ನಾನು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. a convex lens convex ಅಂತಾನೆ ಹೇಳ್ತಿರೋದ್ರಿಂದ I will write focal length in air is plus 20. what is the focal length in water? Focal length in water even the refractive index of water they have given us 1.33. refractive index of glass has been given as 1.5 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. This is what they have given and we have to find out the focal length in water. water ನಲ್ಲಿ ಎಷ್ಟು focal length ಅಂತ ನೋಡಿ ಈ ತರ ಕೊಟ್ಟರೆ ನೋಡಿ ಇಲ್ಲಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಡೇಟಾದಲ್ಲಿ ವಾಟರ್ ಗ್ಲಾಸ್ ಎರಡು ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅಕಸ್ಮಾತ್ R1 R2 ಕೊಟ್ಟಿದ್ದಿದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಮಗೆ ಫಾರ್ಮುಲಾ ಇದೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಬೋದು. ಈಗ ನಾಲ್ಗೆ ಮೆನ್ಷನ್ ಮಾಡಿದೆ ಫೋಕಲ್ ಲೆಂತ್ ಇನ್ ವಾಟರ್ ಅಂತ ಬರ್ಕೊಂಡ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ng by nw minus 1 into 1 over r1 minus 1 over r2. ಈ ಫಾರ್ಮುಲಾ ನಾವು ಉಪಯೋಗಿಸಬಹುದು ಡೈರೆಕ್ಟ್ ಆಗಿ ಯಾವಾಗ ಅಂದ್ರೆ r1 r2 ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದೆ ಬಟ್ ದೇ ಹ್ಯಾವ್ ನಾಟ್ ಗಿವನ್ ಇಟ್ ಕೊಟ್ಟಿದೆ. ಹಾಗಾಗಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಇದೊಂದೇ ಫಾರ್ಮುಲಾದಿಂದ ನಮಗೆ ಆನ್ಸರ್ ಬರೋ ಚಾನ್ಸಸ್ ಇದೆ. ಆದರೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಫೋಕಲ್ ಲೆಂತ್ ಇನ್ ಏರ್ ಫೋಕಲ್ ಲೆಂತ್ ಕೊಟ್ಟಿದೆ ಏರ್ ಅಲ್ಲಿ ಫೋಕಲ್ ಲೆಂತ್. ಹಾಗಾಗಿ ಅದರ ಫಾರ್ಮುಲಾನು ಬರೋದು FA is equal to just ng minus 1 what we got here other one now into 1 over r1 minus 1 over r2. ನೋಡಿ ಅಡ್ವಾಂಟೇಜ್ ಏನು ಅಂತಂದ್ರೆ ಇದನ್ನ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ ಓಕೆ 1 divided by 2 ನಾರು ಮಾಡ್ಕೋಬಹುದು. ಓಕೆ ಹಾಗಾದ್ರೆ ನೋಡಿ ತೊಂದರೆ ಏನಿಲ್ಲ. ಓಕೆ ಇದನ್ನ ಹಾಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡೋಣ. ಆಮೇಲೆ ಬೇಕಾದ್ರೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋಣ. 1 divided by 2 ಅಂತ ನಾನು ಬರ್ಕೊಂಡ್ರೆ FA by FW ಕರೆಕ್ಟ್ then this divided by this. ಹಾಗಾದ್ರೆ ಇದು ಇಲ್ಲಿ ಬಂತು ಇದು ನೇರು. ಅವರು ಇಲ್ಲಿ ನೋಡಿ ಇವೆರಡು ಕ್ಯಾನ್ಸಲ್ ಆಗಬೇಕು. ಹಾಗಾಗಿ ವಿತೌಟ್ ಕನ್ಸಿಡರಿಂಗ್ ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಆಫ್ ದ ಸರ್ಫೇಸಸ್ we can work out the problems. ಹಾಗಾಗಿ R1 R2 ಕೊಡದಲ್ಲ ಕ್ಯಾಲೆಂಡರ್ ಇದೆ, but just go for the ratio that has to be there in your mind. Okay, ಈಗ ನಾವು ಡಿವೈಡ್ ಮಾಡಿರೋದು 1 divided by 2, ಅಂದ್ರೆ ಇದು ಮುಗಿಸ್ಕೋಬೇಕು. ಇಲ್ಲಿ mg by nw minus 1 divided by this is mg minus 1. ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಈ ಕೆಲಸ ಈಸಿ. ಏರ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ವಾಟರ್ ಕಂಡುಹಿಡಿಯಬೇಕು. ಓಕೆ, ಜೊತೆಗೆ ಈ ವ್ಯಾಲ್ಯೂಸ್ ಗಳನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು ಅಷ್ಟೇ. ಅದನ್ನ ಮಾಡಬೇಕಾದ್ರೆ ಫೋಕಲ್ ಇಂದ ಏರ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಸ್ವಲ್ಪ. ಫಾರ್ ದ ಫೋಕಲ್ ಇಂದ ಗಿವನ್ ಇನ್ ಏರ್ 20 divided by ಫೋಕಲ್ ಇಂದ ವಾಟರ್ ಬೇಕು. ನೋಡಿ ಇಲ್ಲಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಇದು Mg by Nw, ಹಾಗಾಗಿ ಅದು Mg minus Nw by Nw ಆಗುತ್ತೆ. ಓಕೆ, ಈಗ ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಅಂದ್ರೆ ಇದೆಷ್ಟು 1.5 divided by 1.33 minus 1 whole divided by 1.5 minus 1. Focal length in water ಅಂದ್ರೆ 20 into 0.5 whole divided by this one, that is 1.5 by 1.33 minus 1. Simplify ಮಾಡಿದ್ರೆ focal length in water comes out to be 78.74 centimeter. 78.74 centimeter. Okay, this is the answer for the third problem. As I mentioned already, I sent the problem 5. Remaining problems I will be discussing in the next class. Examination problems in there. Adana next class I will discuss ಮಾಡ್ತೀನಿ. Okay. Today I will be ending the class. I hope you have understood. If you have any doubt, once the offline classes start, you can come and ask. Otherwise, you will know my number. Okay, call ಮಾಡಬೇಕು, clarification ಕೊಡಬೇಕು. Okay, your side ಎಲ್ಲಾರು ಅಕಸ್ಮಾತ್ ನಂಬರ್ ತಪ್ಪು ಬರೆದಿದ್ರು ಕೂಡ just inform so that I can inform that to other students. ಆ ಥರ ಆಗಿಲ್ಲ ಅಂತ ಅನ್ಸುತ್ತೆ, ಅದಕ್ಕೆ ವರ್ಕೌಟ್ ಮಾಡ್ಕೊಂಡು ಮುಂದೆ ಬರೆದಿದ್ದೆ ಸೊಲ್ಯೂಷನ್. ಸ್ಟಿಲ್ ಓಕೆ, ತಪ್ಪಾಗೋ ಚಾನ್ಸ್ ಇದೆ. ಹಾಗೆ ಅದೇ ತಪ್ಪು ನೀವು ನೋಡ್ಕೊಳ್ಳೋದು ಬೇಡ. ಅಕಸ್ಮಾತ್ ಯಾರಿಗಾರ ಆ ಥರ ಗೊತ್ತಾಗ್ತದೆ ಮಾಡಿ. ಥ್ಯಾಂಕ್ ಯು.